Well, now that we've looked at how we reclaim acidic and/or alkaline soils, let's go back and relate this a little bit to our soil's cation exchange capacity. And I want to relate that in just a little different perspective. I want to look at it in terms of the concept of base saturation. We have cations that exist in the soil, some of which are considered basic cations, others of which are considered acidic cations. And the term base saturation is referring to what percentage of the cations held on the exchange sites are bases versus those that are non-bases or could be considered acidic cations. So in terms of a review, let's take a look at what are the acidic cations. Well, the only real cation of significance in terms of the exchange complex that is acidic is hydrogen. The other cations that are most commonly found on these exchange sites are the exchangeable bases: calcium, magnesium, potassium, sodium, and/or ammonium. So when we talk about the base saturation of a soil, what we're really referring to is what percentage of the soil's total cation exchange capacity is occupied by readily exchangeable basic soil cations. So it's a quantitative measurement, and it is a percentage measurement. If we had 40 milliequivalents per 100 grams of soil of total cation exchange capacity, and 20 of those milliequivalents were occupied by basic soil cations, then 20 of the 40 would be basically 50%. So we would have a soil in that particular example that had a base saturation of 50%. Why is it of significance that we might want to know what the base saturation of a soil is? Well, I think you can see that base saturation is going to be tied very closely to soil pH, because those cations which are in solution are in a direct equilibrium with those cations which are on exchange sites. So base saturation is really giving us an indication of the pH of that particular soil. As we see the soil pH decreasing or becoming more acidic, we would expect to see a corresponding decrease in the percentage of base saturation in that particular soil. Different crops require different levels of base saturation in order to make the best growth. Crops which are very sensitive to lower acidic soil pHs will generally require the highest level of base saturation in order to make good growth.